Hello everyone, my name is Adam Lesser. I'm a science teacher at Salina South High School, and this is a video I'd be using towards the beginning of the class, just to make sure that we're on the same page for how we're going to do investigations throughout the course. So what we're looking at here is critical thinking in the science classroom and how we can use that to learn more about the world around us. As far as looking through our specifics here, kind of our bulleted list of what's going to be going on, those things should look pretty familiar to us. In fact, you might be thinking to yourself, well, that's just the scientific method, and you'd be completely right. In fact, when we look at learning about the world around us, we use the scientific method constantly. We don't even think about it a lot of the times. These 5 different processes are just a way to help us just kind of keep tabs or step through the process when it gets a little bit more difficult. And that's certainly going to be something that we hope to run into some of those problems here this year. So the first thing we want to be able to figure out is just identifying the problem. Most of the time in the classroom that's going to be given to you, but it could be very different depending on just where you're at or what stage of life you're in. For instance, if we think about administration in high schools right now, a huge problem is vaping in the bathroom and how they can be able to work with that or to be able to solve that issue, if you will. Moving on from there, effective research is a critical thing that most students don't have a lot of background with, at least not in the science lab setting. They're probably more used to getting a cookbook style lab where you just go through the steps and you get an expected result. If we're moving towards students actually designing and developing their own lab procedures, then this is a critical role where they actually figure out what sort of information do I need to know if I'm actually answering a problem or answering a question one way or another. And the big part of that is just finding reputable sources. The example on the screen for you, bandhmo.org, is a great example of something that looks like it could be reputable but absolutely is not. But I'll let you guys check that out at a different time. From there, we do want to take that information and actually design an experiment. And honestly, the biggest thing is that we're just keeping the test or the experiment both fair as well as repeatable. We want it to be something that not only can I do in the lab, but other people can follow along and kind of test for themselves to see if it stands up. From there, when you're actually conducting the experiment, this is where students tend to kind of relax a little bit too much. As far as accurate measurements, we kind of don't. We have a habit of just guesstimating and moving on from there. And if we're actually trying to prove something, we want to make sure that we are being as accurate as possible. And a big part of that is kind of being able to recognize any possible mistakes that you might be making. From there, we do want to move on to drawing conclusions. The biggest thing here is that we have to use all that evidence, all that research, basically every single thing we've done so far, to tie it into what we're trying to claim. And this infographic is a great way of showing how that justification should fit in with our evidence. Thanks for watching, and have a great day.